I'd like to kindly welcome you to the second chapter of the first part of my presentation. In this part, I will do my best to explain the method of making formworks of strip foundations, the manner of making a strip foundations itself, as well as the method of preparing it for mortaring full foundation walls. As it can be seen in the film, I will use OSB boards, which first should be cut into strips of a proper width. The width depends on the height of the strip foundations that we are going to build, and the value of it, of course, be read from the project. In our case, the strip foundations will be 30 cm high. In order to strengthen the lower part of the formworks, we will use threaded rods, which will move through the openings whose performance you can see in the film. Such openings should be placed at a distance of 5 cm from the edge of the boards, whereas the spacing between them is approximately 40 cm. Here we can already observe the manner in which the individual elements of the formworks should be combined. As it can be seen, to this end we will use ordinary boards that should be approximately 5 cm longer than the height of the strip foundations. To join the boards with a panel, it is best to use black screws designed for plaster boards, the ones prepared for a wooden construction. From my own practice, these screws are the best for this kind of work. The boards are screwed on in the places where the next panels are joined, as well as in the corners of the construction. The same boards will also help us to strengthen the formworks being built. So, as it can be noticed, they should be screwed on quite densely, approximately every 40 cm from one another at the best. I haven't mentioned so far the thickness of the panel that I used. The thickness of the panel used here is 15 mm, so it may seem to be too thin. However, already in this chapter, we will see that it was perfectly enough. Please notice how the concrete beds discussed in the previous chapter are useful now for building the formworks. They prevent the workers from being exposed to work in humid conditions, which is indeed a great significance, especially when a few rainy days occur. But most of all, they don't need to level the formworks anymore. We made sure beforehand that the concrete beds hold the level perfectly. Therefore, we can now concentrate first of all on appropriate placement of the formworks against the axis of the walls. At this point, I would like to direct your attention to the manner in which we use the previously made openings for threaded rods. As it can be seen, we put a threaded rod of the section of 6 mm through them every 40 cm. Such thickness is perfectly enough to withstand the thrust of the concrete cast with a pump under quite a considerable pressure. Now we need to read the width of the strip foundations from the project. In our case, there are two types of strip foundations. One is 50 and the other 60 cm thick. We now measure such distance using a measure tape and then screw the horizontal boards on from the above that will support the construction being built. The amount of boards that are being screwed on so far is no more than necessary to prevent the formwork from tipping over, because we must also place a reinforcement inside it. A few spacing boards are also placed inside from below, which ought to be removed prior to filling the formworks with concrete, as we shouldn't leave any wooden or other organic elements inside the strip foundation. At this point, it is worthy to notice another implementation of profile boards made by a surveyor in the previous chapter. Here we can observe ropes that are fastened to the nails which map the axis of the walls. At this point, in order to properly place and cut the formworks that were put together, it is necessary to measure 25 cm from the string in case of a strip foundations which are 50 cm wide and 30 cm on each side of the axis in the case of strip foundations that are 60 cm wide. This is yet another time when we can notice that it is not possible to properly build foundations of the building without profile boards. Here we can already see the reinforcement that we'll use to make the strip foundations and to reinforce spot footings, as well as columns placed on them, which in the future will shift the weight of joints and outer lintels. Thus we can observe here crossbars made of deformed bars of 12 mm diameter. The bars intersect every 15 cm and the footings will have an area of 1 meter by 1 meter, thus the crossbars should be slightly smaller, for example 19 by 90 cm. Now you can notice the reinforcement of the strip foundations, which are made of 4 bars of 12 mm thick, linked together with chairs made of smooth bars of 7 mm thick. The diameter of the entire reinforcement is 25 by 20 cm. Such reinforcements can be made on a construction site, in which case chairs should first be cut and properly bent and then the whole construction tied together with a tire wire. The reinforcements can also be commissioned to be made in a place where we buy reinforcement steel. In such case, all we need to do is to place ready parts of reinforcement in the appropriate places and tie them together as shown in the film. This is not a more expensive option, as we will have to pay to workers on a construction site for tying the reinforcements together, particularly in a project like this one, where there are indeed a large number of reinforcements, including those that will be made for ceiling. Some of them will have quite complicated shapes. You will observe it in the part concerning ceiling and reinforced concrete constructions. Now we can see how the already reinforced spot footings with reinforcement of columns secured on them look like. The reinforcement of columns have a diameters of 15 by 15 centimeters. The lower part of their bars is bent at an angle of 90 degrees and tied to the crossbars. Reinforcements of the strip foundations in the corner should either be bent or additionally short bent boards ought to be added and tied to the primary reinforcement. We use a simple tool to tie the bars. The tool is a steel stick pointed at the end and bended in a slightly hooked shape. As a binding material, we will use a steel wire commonly called a tire wire, which, thanks to it being very plastic, can be tied very tightly. We fold into halves the previously cut pieces of wire of approximately 20 cm length, thread them in a place where 2 bars intersect, catch a loop with a K and then twist the wire. Clearly, it is very easy and at the same time very effective. The next task that we can observe is carrying out earthing of a building and lighting protection. You are now witness one of the ways in which these works can be performed. Due to the fact that we didn't have electricity on this construction site, we couldn't use a welder. Therefore, we accomplished our aim by running a hoop iron around the strip foundations, and we fastened it tightly to the reinforcement. Obviously, the hoop iron can't be cut in any place, making a closed circuit. As it can be seen, in every corner of the building the hoop iron will be placed above the foundation and linked with the lighting protection, while in an utility room it will be connected to an electric installation to serve as earthing. Another method of carrying out earthing is to weld one of the reinforcement bars around the building. In order to form a closed circuit, it is enough to additionally weld short strip of a hoop iron to the circuit prepared in this way and place them above the foundation. That is the quickest method can be used. Another method can be to make a rim by burying a hoop iron around the building without connecting it to a reinforcement. After carrying out earthing, we will strengthen the formworks precisely using boards and then move on to the cast concrete of a strip foundation. To make strip foundation and spot footings, we will use structural concrete of B20 or B25 class. In case of humid areas, concrete with increased humidity resistance may be applied. This type of concrete must necessarily be ordered in a batching plant, and a certificate must be obtained for such a blend. The best solution will also be to order a concrete pump, thanks to which we will easily cast an appropriate amount of concrete everywhere in the foundation. If building takes place on a plot where a batching plant can easily approach from each side of the foundation and a construction on the strip foundation is simple, we may abandon the idea of using a concrete pump and thus save some money. Personally, however, I don't recommend such solutions. Works may then take a long time and concrete may start to dry, which will cause haste and result in poor vibration and smoothing of concrete. Please notice that due to the fact that the boards which we use to strengthen the formworks are 5 cm longer than the height of the strip foundations, they will now not interfere with smoothing the surface of concrete. The concrete cover around reinforcement should be at least 5 cm and the reinforcement can on no account stick out from the strip foundation in any place whatsoever. We need to make sure of that to prevent the reinforcement from being exposed to corrosion. Thanks to placing the strip foundation on a concrete bed and inside the formworks, it is not possible for concrete being cast now to mix with the ground, neither is it exposed to a quick loss of water, owing to which it retains the entirety of its properties. Placing the strip foundations in the formworks allows also for a proper carrying out of waterproof insulation. After casting the concrete, it should necessarily be vibrated. To this end, we will use a device that can be observed in the film, commonly called a vibration poker. Watching construction sites, one may often notice that this stage of works is totally overlooked by contractors. More often than not, it is done sloppily. Strip foundations are not properly insulated and reinforcements remain exposed to corrosion, plus the surface is not level, all of which cause constructors to strive to remedy the issue in the next stage, that is mortaring a load-bearing walls. and even out the level with a certain amount of mortar. This naturally affects the solidity of the whole construction. For this reason, it is important to raise a construction manager's awareness in this regard and not to allow ourselves to be decided by contractors, some of whom have a habit of speeding up the building process at the cost of its solidity. As a rule, this entails the necessity to correct many things, which in turn cause delay in works and often increase in costs. After completing this task, we will move on to smoothing a surface on the strip foundation. Initially, we may use an ordinary shovel to roughly cast and level concrete, as well as to remove in excess. Then we will polish the strip foundation using styrofoam or steel trowel. It is best to do this smoothly, since the surface will also be insulated, so the less porosity and roughness, the better. Prior to taking off the formwork, concrete should be taken care of, meaning it should be poured with plenty of water for a few days. Luckily in this case, it so happened that it rained a little for several days, so additional watering wasn't necessary. After a few days, we may take the formworks off. It can be seen that the foundation was made perfectly, which of course will bring good results in the next stage. As I have been clearing from the very beginning, thoroughness of performance indeed pays off. However, we still need to insulate the strip foundations. In this part I will show how to carry out a perimeter insulation, whereas a horizontal insulation will be presented in the next chapter, which deals with mortaring foundation walls. To make a perimeter insulation, we will use an asphalt putty. The strip foundations should be painted with the putty twice. When they are dry, they should be buried and the ground thickened. While transporting concrete blocks, they ought to be placed inside the foundation to make mortaring them more convenient. We should bear in mind that the blocks are really heavy, and there is no need to carry them around the entire construction site for no reason. This part ends here. I invite you to watch the next chapter, which concerns mortaring load-bearing walls.